Dear students, hello everyone. Welcome to the computer-aided manufacturing class. Today, we will discuss the automatic programming of hole machining, milling. Create a spot drilling process. Start creating a spot drilling process. Select the type as hole making. The process subtype as spot drilling, and the geometry as workpiece. Create a new tool. Select the tool subtype as spot drilling, and specify the name as spot drill. Specify the diameter as 10, and the tool number and compensation register number as 4. Specify the feature geometry. Select the centers of all holes on the part as the drilling point, and optimize the sorting. Set the feed rate and speed. The spindle speed revolution per minute is 2000, and the cutting feed rate is 600 mm per minute. Generate a tool path and check it. Create a drilling process. Select the process subtype as drilling. Create a new tool. Select the tool subtype as drill. Specify the name as T5 STD drill 7.8. Set the diameter as 7.8, and the tool number and compensation register number as 5. Specify the feature geometry. Select the hole features and optimize the sorting. Set the tool path. Select the motion output as machine cycle, and the cycle type as drill deep hole. Set the cutting strategy parameters, and the distances of the top offset and the bottom offset are 1. Set a non-cutting movement. The safety setting option is use inherited, and the transfer type is direct. Set the feed rate and speed. The spindle speed revolution per minute is 1000, and the cutting feed rate is 200 mm per minute. Generate the tool path and check it. Create a tapping process. Select the process subtype as drilling. Create a new tool. Select the tool subtype as tap. Specify the name as tapping. Set the diameter and the tool number and compensation register number as 5. Specify the feature geometry. Select the hole features and optimize the sorting. Set a tool path. Select the motion output as machining cycle, and the cycle type as standard tapping. Set the cutting strategy parameters, and the distances of the top offset and the bottom offset are 1. Set the non-cutting movement. The safety setting option is use inherited, and the transfer type is direct. Set the feed rate and speed. The spindle speed revolution per minute is 500, and the cutting feed rate is 400 mm per minute. Generate a tool path and check it. Create a reaming process. Create a new reaming tool. Select the tool subtype as reamer. Specify the name as reamer. Set the diameter as 12 and the tool number and compensation register number as 0. Create a reaming process. Select the process subtype as reaming. Set the feed rate and speed. The spindle speed revolution per minute is 600, and the cutting feed rate is 1000 mm per minute. Generate a tool path. Create a counter-boring process. Select the process subtype as counter-boring. Create a new tool. Select the tool subtype as counter-bore. Specify the name as counter-boring tool 1. Set the diameter as 30, and the tool number and compensation register number as 0. Specify the part and blank geometries. Set the feed rate and speed. The spindle speed revolution per minute is 600, and the cutting feed rate is 1000 mm per minute. Generate a tool path. In this class, we have understood: first, create a spot drilling process. Second, create a drilling process. Third, create a tapping process. Fourth, create a reaming process. Fifth, create a counter-boring process. Thank you all.
Hello, class. Welcome to the Computer-Aided Manufacturing course. In this lesson, we learn about hole machining milling. First, learn centering drill. Second, learn to drill holes. Third, learn tapping. The fourth, learning reaming. Fifth, learn to spot the hole. First, learn centering drill. Firstly, create a hole adding centering drill. The process steps are as follows. Insert the toolbar first. Click the Create Operation button. In the Insert toolbar, the system opens the Create Operation dialog box, as shown in Figure 1. Let's now open the Create Operation dialog box. Enter the processing environment. Create an operation. Open the Create Tool dialog box. We have already opened it, as shown in Figure 1. Set the type to hole making. Then we choose hole making. Choose the first one. The working procedure is centering drilling. The geometry is workpiece. Select workpiece as the tool geometry. We don't have to choose geometry here yet. Take this one. We didn't create a tool here. The process of creating a tool. Later, we'll watch the video of creating a tool. Choose the first one. Click OK. We entered the Centering Drilling Process dialog box, as shown in Figure 2. Click OK. Need to create a tool. Let's create a tool first. Let's click OK first. Create props here. Click Create Tool in the upper left corner. Create a tool. It's also hole making. Choose the fourth one. Expand the tool set. In the Centering Drill dialog box, click the New Tool button. The New Tool dialog box pops up. Select the tool type as Centering Drill. Spot Drill. Specify a name. Follow the steps. Choose the fourth one. Click OK. We'll create the tool. Tool. We set the parameters according to here. The diameter is 10. Specify feature geometry. In the Centering Drill Operation dialog box, click the Feature Geometry button. The dialog box Feature Geometry pops up, as shown in Figure 5. Select parts in the graphics area. The centers of all holes of the part will be defined as the drilling point, as shown in Figure 6. It's right here. Pick the center point of the groove in the graphics area, as shown in Fig. 7, will be highlighted in the list. The center point of this groove, we didn't use this. Let's take a look at it later. In the Specify Feature Geometry dialog box, in the Sequence group, select Shortest Track as the optimization method. Click Reorder List, as shown in Fig. 9. This is the removal point. Select the optimization method here. Shortest distance rearrangement. Click the OK button. Return to the Centering Drill Operation dialog box. Click the Feed Rate and Speed buttons. Ejection feed rate and speed set 2600. Click the Calculate button. Click OK. Generate tool path. Determine the process. Let's choose this geometry. There is nothing wrong with cutting parameters. Click OK. There is non-cutting movement. After choosing, here's 2000. The feed rate is 2000. The speed is 600. The centering drill is completed. Then the next step is drilling. Creating a hole machining step for drilling machining. Create a drilling operation. The second one here, drilling process. Also hole making. The second is to choose this hole. We create a tool. New tool dialog box. Select the drilling tool. To set up such a drill, the name is like this. Let's leave this alone. Let's create a knife first. Tool for drilling holes. This is it. Then set it to 8 centimeters. This is the drilling process. We choose the tool we just created. Select Program. Click OK. These 4 holes should be machined. Look at this list. Add or subtract right here. Click OK. Select cutting parameters here. Right here. In the drilling process dialog box, click the Specify Feature Geometry button. The system pop up the Specify Feature Type Geometry dialog box. Adjust the viewing angle to the top view in the graphics window. Select the 4 hole features on the left, as shown in Fig. 13. This is the selection of hole features. We chose 4. This is also the feature of selecting holes. In the Assigned Geometry dialog box sequence, select the shortest knife track as the optimization method. Optimization method. The last introduction was over here. It's called characteristics. We won't set it here. Look for this feature first. Here. The short tool path here. Click OK. Then click Reselect Sorted List. According to the shortest distance, rearrange. Click the OK button. Return to the Drilling Procedure dialog box. Tool Path Setting. In the Drilling Operation dialog box, select the motion output as Machining Cycle of Machine Tool. The circulation type is drilling, deep hole. Motion output is machine cycle. Drilling, deep hole. This is the drill, deep. Machine tool processing cycle. The system pops up the Loop Parameters dialog box. Set the step depth increment to constant. The maximum distance is 5 mm. That is, we didn't set it up. Let's set it up again. Let's move on. Click Cutting Parameters. In the Drilling Process dialog box, open the Cutting Parameters dialog box. Display that Policy tab. Set the top offset distance to 1. The bottom offset distance is 1. Then click OK. We click on the cutting parameter. Option 1. Click OK. It can be completed. Go on. In the Drilling Process dialog box, click Non-Cutting Move. Open the Non-Cutting Move dialog box. In the Transfer Vertical Line Express option, set the Security Setting option to use Inherited. Specifies that the transfer type between features is direct, as shown in Fig. 18. Click the OK button. In Transfer Vertical Line Fast, let's find the non-cutting movement first. Here, Transfer Vertical Line Fast. Transfer Vertical Line Repeat. Click here. Let's see what to choose. Use Inherited. We'll use Using Inherited. Click OK. Then set the feed rate and speed. Click the feed rate and speed. The feed rate and speed dialog box pops up. Set the spindle speed to 1000. The cutting feed rate is 200 mm/m. Click OK. The drilling program is set up. This course ends here first. Hello, students. Welcome to the Computer-Aided Manufacturing course. Today, we will learn about tapping, reaming, and countersinking in the hole processing part. Let's continue to study. Create a tapping process. The steps are as follows. Click the Create Operation button. In the Insert toolbar, the system opens the Create Operation dialog box. Select the subtype of operation as drilling. Just click the OK button here. Opens the Tapping Operation dialog box. Let's build a new tool first. Expand Tools in the Tapping dialog box. Click New Tool. The New Tool dialog box pops up. Select the tool subtype Tap. Click the OK button. The dialog box will open. Set the diameter. The tool number and compensation register are 5. Click the OK button. Return to the drilling process dialog box. Create an operation. Tap should be this. Click OK. Number 1 cutter. Set to 8. This is the creation process. This is tapping. Point to point. This piece selects the tap. This is the tool we just created. Select Workpiece. Click OK. We entered the dialog box of tapping process. Specifies the feature geometry. In the tapping process dialog box, click the Specify Feature Geometry button. The system will pop up. Specify Feature Geometry Type Volume dialog box. Adjust the viewing angle to the top view. In the Graphics area box, select the 4 hole features on the left. Select the 4 hole features on the right. In the Specify Feature Combination dialog box, click Sequence. The shortest tool path is selected as the optimization method. Click the Reorder button. Step by step. This is the specified bottom surface. Select the bottom surface. The tools have been chosen. Select the 4 hole features on the left in the Graphics area box. Select the 4 hole features on the right. The short tool path is selected as that optimization method. If not, leave it alone. Click OK. In the drilling operation dialog box, select the motion output as machining cycle of machine tool. The cycle type is standard tapping. The depth increment distance is changed to 5. The maximum distance is 3. Click the OK button, return to the tapping dialog box and finish. In the tapping process dialog box, click the Cutting Parameters button. Open the Cutting Parameters dialog box. Display that policy tab. Set the distance of the top offset to 1. The bottom offset distance is 1. Click OK. Not in this version. Set the non-cutting movement. The rotation speed is 500. The feed rate is 400. Generate tool path. Click OK. Generated. Keep looking at the reaming. New tools are built here. In the reaming operation dialog box, expand the Tools option group. Click the New Tool button. The Create Tool dialog box pops up. Select the subtype of tool as reaming. Specify the name as reaming as shown in Fig. 26. Create tool for new tool. Don't change the name yet. Create a new tool first. The tool number and compensator registration number are 0 as shown in Fig. 27. Return to the reaming process dialog box. Create a reaming operation. Click the Create Operation button in the Insert toolbar. The Create Operation dialog box opens. Select the subtype of operation as reaming. Click OK. Open the reaming process dialog box. The first in the second row. Select the tool we just created. This is the reaming. Click OK. Select a face. Select the bottom surface. Here we have chosen the tools. The cycle type is standard. Here, the spindle speed is directly designed to be 600. The feed rate is 100. Click OK. Generate tool path. The minimum speed here is 600. The feed rate is 100. Click OK. Let's learn about countersinking. The steps are as follows. Create a new tool first. In the counterboring process dialog box, expand the Tools option group. Click New. The Create Tool dialog box pops up. Select the subtype of the tool as the countersink. The specified name is -1. Click the OK button. The system opens the Counter Cutter dialog box. Set the diameter to 30. The tool number and compensation register number are 0. Click the OK button. Create a new tool countersink -1. Click OK. Let's set it to 10 here. Create an operation. Select the newly created counterboring tool. With this geometry, click OK. Set the spindle speed 600. The cutting feed rate is 100. There's a mistake here. It should be 280. The speed is 200. The feed rate is 100. Click OK. This is the tool path of the counter bore. Click OK. The whole machining milling course. In this chapter is over. Thank you, class.